I am Dr. Ramla Devi, Assistant Professor of Chemistry, PG. Today we are going to see about the corrosion and its type and how to prevent the metal and its environment from the corrosions. First, initially, what is corrosion means? It is one of the natural process occurring on the environment. So it's usually made up on the metal or metal surfaces. So first, initially it can be defined as the destruction and deterioration of the metal and the metal structure with its environment. It is happened by the air, water and other gases also. First is the destruction means the destruction is the physical attack on the metal surface of the metal. Deterioration means the gases attacked on the chemical interior structure of the metals. So normally the corrosion is the slow process. It takes more than 1 year of time. The corrosion rate is measured by weight loss method. The best example of corrosion is the rusting of iron. So the figure shows the iron can be corroded by the atmosphere. So it is the chemical reaction of iron and the oxygen molecule. So nowadays the research is more focused on the prevention of metals from the corrosion because the metals are corroded in every field of utilities, transportation, infrastructure, government and manufacturing. They are spending totally 276 billion per year for the prevention of metals from the corrosions. These type of corrosions usually occur by two ways. One is dry corrosion, another one is wet or electrochemical corrosion. If it is the dry corrosion means it is the direct attack of oxygen or any other molecules on the metal surface. If it is the dry means it is the direct only attack of gases without liquid phases. Usually the dry corrosion is occurred at the high temperature without any liquid medium. So this is the air and water. If it is the attack by oxygen molecule on the metal surface, it is the dry corrosion. It is the water, it is in the presence of aqueous medium or electrolyte. The corrosion happens, it is called wet corrosions. So the final product is the corrosion product. So in the type of dry corrosion, there is also two types. One is oxidation corrosion or otherwise corrosion by gases. So it is the direct attack of oxygen molecules on the metal surface. The attack of metal surface towards the oxygen by van der Waals forces. So the simple mechanism is explained for the oxidative corrosion is at a high temperature the metal undergoes oxidation and it loses electrons. So the metal becomes metal ions. So 2m plus m plus ions. So the loss of electron is gained by the oxygen molecule and forms the oxide ions. So the oxygen gains the electrons from the metal ion. So it becomes 2n plus 2n minus ions. So finally the m plus ions and n minus ions, O minus ions form the metal oxide on the surface of the metal. This is mostly happened in the presence of transition metals. Some of the noble metals and the other transition metals also undergo corrosions. But noble metals form an unstable corrosion, but the transition metals undergo these stable corrosions. And the next one is the corrosion by other gases like CO2, Cl2, H2S. These are undergo corrosions from the metals. It has a high affinity with the metals and so it forms another form of corrosions. Next important type one is wet corrosions. Wet corrosion is nothing but it is the formation of corrosion on the metal surface in the presence of aqueous solutions or solutions having high conducting solutions. So the wet corrosion takes place in the environment more than 60% of relative humidity. So the wet corrosion is efficient in the presence of high conducting solution. Example, salt containing solution sodium chloride having more corrosion will be occur. So in the case of electrochemical cell, the corrosion will be wet corrosion will be occur. So the electrochemical cell consists of anode, cathode, a connection and an electrolyte. The anode is the part and the most of the corrosion takes place. So in that place the oxidation will occur and the loss of electrons will also be happen. At the cathode it will be in the form of pure metal or any other conducting material. So it will gain the electron from the anode part. So the connection is nothing but then the transfer of electrons from the anode to cathode. It will be in the physical form of contact or set from some form of wire. Next one is the electrolyte. Electrolyte must also be present in the electrolyte cell because it having to transport ions from anode to cathode, and it also be must present in the formation of corrosions. So this is the anode part, this is the cathode, this is the current flow between the anode to cathode because the electrons are transferred from anode to cathode. So the current generation will occur on the surface of the metal and the corrosion will be formed on the surface of the metal. The mechanism of electrochemical corrosion. In the anodic corrosion, first the metal undergoes oxidation at the point applying the potential. The dissolution of metal happen. So in the dissolution of metals, the electrons get oxidized and it leaves from the anode surface. At the cathode part, the hydrogen evolution will occur, and at the same time the hydrogen oxygen absorption also be happen on the surface of the cathode. The 2H plus ions gain electron from the anode to it will be evaluate as a H2 gas. At the same time, the oxygen molecules absorbs the 4 proton molecule and the electron molecule. The water molecule will be produced in the case of acidic medium. In the case of basic medium, the same case, the 4 OH minus ions are produced. So there are different types of corrosions are formed. First one is galvanic corrosion. Galvanic corrosion is nothing but it's same as the electrochemical corrosion. When same last slide we are saying, when two metals are placed in contact with each other in the presence of conducting solution, example electrolyte solutions, it will form the corrosion on the anode surface. Here is the example. Here we are taking aluminium and copper. Aluminium is the anode. The aluminium metal gets dissolved and the electron go to the copper surface and the aluminium metal get corroded on the anodic part. Next one is the concentration cell surface, cell corrosion. So it is same as that of galvanic cell corrosion. So same, the two metals are placed in contact with different air conditions. The corrosion will also be happened. Next one is pitting corrosion. So it is the most form of corrosion occurring on the metal surface. It is a localized attack of a gaseous molecule on one point of the metal and it will be corroded and it forms the pit and the cavities. So it is usually seen on the railway tracks and any other metals. So it is completely deteriorated from the pitting corrosions. Next one is stress corrosions. So it is formed by the tensile strength. When we are applying the stress on the metal, the metal will be corroded and the stress will be go into the interior structure of the metal and it will be corroded. So this is the broken part of the material. So this is the stress part and the stress will be included into the chemical structures. Next one is the important point, how to measure the corrosion rate. So usually the weight loss method is the important technique to measure the corrosion rate. So when the metal when we are analyzing the sample, we use the weighing balance method is used. So if the species are analyzed, we want to check it and the species analysis taken out into the environment and put it in a certain period of time. So it undergoes oxidation and corrosion will be happen. After a certain period of time, the species can be removed and it can be weighed. So in the corrosion, if it happens, the weight loss is directly showing. So it indicates the metal can be corroded on the surface. Next one is the factors affecting the corrosions. There are so many factors affecting the corrosion. The two important points are nature of the metal and the nature of the environment. In the case of nature of the metal, that is positions in electrochemical series, positions in galvanic series. If the two metals are present, when we are exposing to the electrolyte solution, the metals having less reduction potential, it easily undergo the corrosions. So if the silver having the lowest reduction potential, so it will easily corrode and easily oxidized on the surface. And the next case is if the greater difference between the anode and cathode and the faster the corrosions. And next one is the over voltage. If we are applying the over potential more than the normal reactions, the hydrogen reaction will be occur. The corrosion rate will be faster. Next one is the area and the distance. So if the area of the anode is greater than the cathode, so there is a normal reaction. But the anode area is smaller than the cathode, the anodic correction will be less and more electrons needed for the cathode. So in that time, the corrosion will be rate would be twice than the normal reactions. Next one is the passivation. So passivation is the important step needed for the prevention of corrosion. So there are so many steps taken for that. So the important one is passivation, because the dry corrosion is encouraged in this type, because if the oxide layer is formed on the metal surface, so it will form and corrode. So if, this is acting as a protecting layer for the metal. If any other gases come to attack on the metal surface, it protects the metals and avoid the corrosion by any other gases. This form of layer is known as passivation layer, and any other cathodic protection layer materials are also be used. Thank you.